Hello, and welcome to my channel. In this lesson, we are going to learn about evaporation that's happening around you every day. Let's begin with the basic definition. Evaporation is the process in which a liquid changes into gas. For example, when water kept in an open dish, it slowly disappears. Do you know, my dear students, water never disappeared. It just changed into gaseous state that finally mixed with air. So water never disappeared, it just evaporated. Now what is condensation? Condensation is the reverse of evaporation. In condensation, gas changes into liquid. A very common example is when you keep a cold glass of water outside on a warm day. You will notice tiny droplets of water forming on the outside surface of the glass. Water vapor present in the air around glass cooled down. That cooled vapor turned back into liquid water in the form of droplets. This whole process is known as condensation. How does evaporation works? In any liquid, the molecules are always moving. Some molecules have low energy, while others have much higher energy. The molecules having more than average kinetic energy overcome attractive forces among the molecules and escape from the surface of the liquid. This conversion of liquid water into gas is called evaporation. How evaporation causes cooling? Evaporation causes cooling because it removes heat from the surface where it occurs. For example, when you put a drop of alcohol on your skin, it begins to evaporate. To do this, the liquid absorbs heat energy from your skin. As your skin loses heat, you feel a cooling sensation. During evaporation, the molecules with the highest energy escape from the surface of the liquid and turn into vapor. When these fast-moving molecules leave, they take away heat energy with them. The rate of evaporation does not remain same under all conditions. It depends upon several factors, like surface area, temperature, intermolecular forces, humidity of air, and wind speed. Let me explain one by one. How evaporation affected by surface area. The larger the surface area, the greater the rate of evaporation, because more molecules are exposed to the air and can escape at the same time. For example, if you pour hot tea into a saucer, instead of keeping it in a cup, it cools more quickly. This is because the saucer has a larger surface area, allowing more molecules to evaporate faster from smaller surface of the cup. How temperature affects evaporation. The rate of evaporation increases with temperature. When temperature rises, the kinetic energy of liquid molecules increases. Due to this, more molecules escape as vapor. For example, hot water evaporates faster than cold water, as the molecules in hot water move faster and have enough energy to change into vapor. The third factor is intermolecular forces, the forces of attraction between molecules. If the forces are very strong, it becomes harder for molecules to escape, so less will be the rate of evaporation. For example, water has stronger intermolecular forces than alcohol. That's why when you spill alcohol on the floor, it vanishes quickly, while water takes much longer time to disappear. The humidity of surrounding air also affects evaporation. Humidity means the amount of water vapor present in air. If the air is already humid, fewer water molecules can escape from the liquid surface. Therefore, evaporation decreases when humidity is high and increases when humidity is low. For example, clothes take longer to dry on a humid day than a sunny day with less humidity because it slows down evaporation. The wind speed also plays an important role in evaporation. When wind blows over the surface of a liquid, it removes the vapor molecules that have just escaped. This allows more molecules from the liquid to evaporate. Therefore, faster wind speed increases the rate of evaporation. For example, clothes dry faster on a windy day because moving air helps more water to evaporate. Thanks for watching. Don't forget to like, share and subscribe to our channel for more educational content.